Good day everybody and welcome back to my channel. So in the last video, at some point I had measured the VGS drive for those JFETs and it was 5.8 or minus 5.8 volts relative to source, like it should be. And when I took these two transistors off, there was no VGS, so I put them back on. I can't remember why. I was just trying to work something. Oh, that's right, because I realised I needed them in because it's all DC coupled. I need that diff pair with the alpha diff pair because they work together in order to diagnose it. So I put them back on and I measured the VGS, and all of a sudden, hey, I've just made a discovery, but we'll get to that in a minute. All of a sudden, it was 6.8 volts. So before it was 5.8 volts, and then it moved up to 6.8 volts. So I thought, is one of these transistors buggered? I put them on all the testers, came up good. I thought maybe they're breaking down under voltage, so I put them back in. Tried it, nothing changed. I thought I'll swap them around because if one of them's breaking down, I'll swap it around. It'll do that on the other side and it will be the opposite condition. It's a diff pair. No. That was just completely random. Anyhow, the next observation that I've just made just now that I said I was going to get to in a sec is I ended up removing the first transistors of the Darlington, triple Darlington output to isolate the output from all the input section, the two diff pairs, the max power adjust, the idle set, all that. So that's still powered up and we can work on it. It's just got feedback from an unpowered output stage that it has no control over. So with those two out and no feedback, this is what's gotten interesting to me. The drive's gone again. So again, the drive disappeared when I took these two out, which I'll take you to the schematic. Where's my mouse? Sorry, my apologies. So when I took these two out, when I took those two out, I lost the drive here. So I put them back in and then the drive ended up being 6.8. Now, I don't know that it's supposed to be 5.8 volts anyway, because if you look here, this goes up to the 15 volt. Oh no, it actually goes up to the bases of these. My bad. Well, anyway, it's still kind of referenced to 15 volts, but I don't know how this circuit's working, but there is a diode junction here, a transistor which has a voltage drop on it relative to what its base is set to, and 5.68 volt Zener. So that could have just been coincidence that we got 5.68 volts and now 6.8 volts, but I just thought that was something interesting to note. And that's where we're up to now. Like I said, also the VGS disappears with the first two of the Darlington removed. And when I say the first two of the Darlington, what I mean is Q123 and Q131 and Q133. The first two drivers for the buffers, whatever you want to call them, for the triple Darlington output. So that's where I'm up to now. I've got the diff pair and that isolated. These are just tacked on by their pins. They're not soldered down. They don't heat up anyway, not with the amp not running. So that's fine for now, just for testing. I didn't want to bother soldering them back down properly with the heat spreaders because they might have to come off again. I don't want to keep having to... The less heat and force and all that that I subject the board to, the better. So, you know. Anyway, far out. It's already gotten there. A lot of stuff's come off and gone back on. But anyway. So I'm going to start taking measurements of the first diff pair and the second diff pair and just see if I can make sense of the voltages on it. But more importantly, I'm going to start at the max power adjust circuit and see if I can make sense of that. Now, the thing that I find interesting about the max power circuit is if I look across, that's that transistor with the diode on one side of it and the 5.68 volt Zener on the other. If I look across the Zener and the diode, I've got this 4.9 volts. And then if I look across the diode and the Zener here, I've got the same voltage. Now the max power adjust, as I pointed out, it's got a 5.68 volt Zener, some voltage drop on that transistor set by this pot, and then another normal diode, so like 0.6, 0.7 volts at least. So I don't understand why that voltage is so small. Obviously it's not getting enough power. So what I was thinking is maybe that's where I need to start, because the entire time that I keep coming back, whether it was from the right channel or the left channel, it kept leading me back to the input section, and we found problems on the input section. Popped JFETs and caps that are not too good anymore, but I doubt that was what's causing the problem. But I'm just replacing them anyway because they're not too good. They're on the slightly leaky side almost, and it's like they're taking a fairly excessive time to come down. That may be because they've been nowhere near their full voltage for years and been passing AC, and it's just messed with the chemistry inside them. And after I leakage tested them at their rated voltage, it reformed them, you know, who knows, but they certainly weren't good when I pulled them out. And I can tell you it wasn't just like a minute or two for the leakage to come down, it was a little bit more because I was doing something else and I turned around and it eventually did come back down. But it's supposed to come down within the first minute to 4 microamps, and after 2 minutes 3 microamps I think it was. So yeah, they were on the edge of leaky, and certainly leaky when first turned on for longer than what they should have been, and the capacitance on one was only half the value, the other one was about 3/4 of the value. So yeah. Alright, so I'm going to pause the video, have a look at the section I'm on today and try and make sense of what I need to be looking for basically, and I'll come back and we'll work from there. Well, something that just caught my attention is that this doesn't actually have a VBA multiplier. It's set up like a VBA multiplier, but it's not on the heatsink. It actually goes to what you would call a what is it? An active bias arrangement, self-biasing. Not just with diodes, obviously, but yeah, current sensing, basically. Self-biasing from voltage differentials on each side, and then there's current sensing for the max power adjust. Anyway, so that's how they're setting all that max power and idle adjust. Anyway, those are the two circuits that I'm interested in at the moment, because I've got a funny feeling that one of those two circuits has something wrong with it. If it's not one of those two, it's the those two diff pairs. It's got to be something around here. So I'm just going to get to it and I'll report my findings, but I just wanted to point that out. Alright, well, I've already found something interesting. I just went to have a look at the bases of the first two diff pair. Now, we've got this pair over here, and on one base there's that 1.2 volts that's on the output, which makes sense. And on the other base, 15.69 volts. On these two, I've got 0.350 and 15. Now, what I can't understand is how is there 1.2 volts on this one, because I'll just show you on the schematic. Q116, it's actually on the top. Q116 is this, and there's a capacitor there, right? There's a capacitor here, and then you've got negative feedback. Now, I thought that, how do I explain this? I thought that, well, for one, it's negative feedback. This should be cancelling out. If there's a volt coming back in here, it should be cancelling it out so that it's not present on the output. So I'm now wondering if I've got something wrong in this path here. So I'm going to go investigate that now and come back and tell you what I find. But yeah, it looks like we've got problems on both channels. I'm not going to lie. Could be, like I said, something related through that mute circuit, because there are things referenced to, say, signal grounds and other things that can move up and down, whereas the power rails can't. So it is a possibility, even though it's clamped to the 15 volt rail with that Zener diode, as I pointed out. But I'm going to do some testing in this area now, and I'll report my findings. Alright, I finally got some actual time to just sit down and work on this. So I've already done a few things. I'm just going to show you guys some things in the schematic. So the right channel had an offset of 1.2 volts on the output with, I can't remember what it was. I'd pulled something out back here. I'm just trying to remember because I've got a few parts off the board at the moment, so it's hard to remember what it was. But anyway, there was, I think it was the driver transistors. I think so. Anyway, I thought it was coming, I measured the same 1.2 volts on each base on every junction, so I could see that it was just getting fed through base emitter resistors or this center line here. Only if this transistor's broken down, I guess. But yeah, so, or through, no, that doesn't really make sense. Anyway, so look, I kind of got the shits, and I thought about it, and I was like, well, look, I know something's wrong in this section here in the middle of the amp. Well, closer back to the beginning. And I've spent so many hours walking in and out, like one day here, one day there, a couple of hours here, a couple of hours there. Adds up. It actually adds up to quite a bit of time. So what I did is initially I just took the drive transistors off, the first drivers of the Darlington output, and I lifted the negative feedback resistor. Still, as soon as I did that, sorry, no, when I removed the drive transistors here, now it's coming back to me. I still had the voltage on the output. When I removed the negative feedback resistor, I think that's when it went away. I could be wrong here. I didn't video it. I was just playing around with it, and honestly, none of the discoveries I made really made any sense to me. So I got the shits, and I said to myself, well, look, if I'm not getting anywhere staring at the circuit trying to make sense of it, what's the point in trying to, keep going like that? I know the problems in this area. It's going to be quicker if I just take all the transistors out the circuit I think the problem's in and test them, and just refit them. Like it's going to take 15 minutes to do that compared to hours. So I started that approach. And this is where it got really interesting. They're all good. Nothing wrong with them. So, the output stage is good. I've already put a few things back too, incidentally. There's a few things that I haven't taken back off since last time they were off because I've already tested them. But anyway, I was thinking, well, okay, maybe I might have to go back to the start where I started at. So I'm starting to wonder if this MOSFET switching, the rail switching circuit has now got something to do with it, because I've literally isolated everything. There is nothing left in there that could cause this problem. I've taken all the parts out in the amplifier section that could cause this problem. Tested them, they're all good. I can't make sense of it. I've never been this baffled over an amplifier with, offset on outputs. It's usually pretty easy to find. So I'm sitting here honestly spinning out. I've thought has a low resistance, low value resistor like 100R, 330R, something like that gone open. And honestly, I'm getting close to testing low value resistors because it doesn't make sense. But I thought before I go that far, I might as well, since I've already taken half the stuff off the board, just continue. I get the feeling I might actually give up on this one. I don't know. I really don't know. I don't know what to say. I can't find any faults. And the only faults I have found aren't the whole picture. There's still more wrong with it. So it's not a fix. So I'm going to start back at the start, because sometimes in electronics, when you're not getting anywhere and you've gone all the way through a circuit, you're missing something back at where you started, right? It's something I've learned over the years. Just forget where you're up to, go back to the start. If you've spent too long on something, you probably missed something. So this could be craziness, but I'm going to pull the MOSFETs. I'm going to individually test them out of circuit, and then I'm going to have a careful look over the board with what components I've got pulled off. Because I believe at the moment, yes, I need to remove this diff pair and this diff pair, because if I power it up at the moment, one of these transistors will get smoked. It's kind of hard to explain why, but basically it's going to turn hard on because the other transistors that were keeping it off are not on the board, right? So what's going to happen is it's going to turn on hard, and it's got the whole high voltage rail across its collector to emitter, so it'll go up in smoke. Q123 and Q124. So before I power it up, I've got to take them off or put other transistors back on. But maybe I should actually just do that now before I accidentally power it up. I think I'll do that now. I'll just take them off, put them in a bag, label them, put them in a bag, and yeah. Wait, are these all the same transistor? It should be, eh? Yeah, they are. Cool. Okay, I'll take all those off. I'll put them in a bag. Then I'll take the MOSFETs off, because the thing I was going to do after I take the MOSFETs off was turn it back on and see what the rails look like. Sorry, not what the rails look like. What the circuit looks like when it's not powered from the high voltage only rail. But I do realise, obviously, to do this, I'm going to have to put the circuit back because I've taken half of it off. I've taken that transistor, that one there, them two, that one, those two, that one. I've taken quite a few off. That one. Yeah. So, yes. Basically, what I did is I looked at the schematic, the area where the fault was, or where I thought it was. I said to myself, whatever transistors are basically coupled junction to junction. So how can I explain this? Any transistors that coupled junction to junction, like one junction of one transistor is in parallel to a junction of another transistor, meaning if you go to test it with a meter, one could be completely open, but you'll read the other junction and think both transistors are good. So all the transistors that were interconnected like that, I removed. And I removed the maxed power adjust and the bias transistor and the transistor that feeds back from the outputs to the max power adjust. All the suspicious stuff. And it all tested good. So, yeah, go figure. Alright. Enough talking. I just wanted to fill everyone in. Also, laugh at me if you want. I totally obliterated this pot. I didn't even realize until after I had removed the transistor, but my hot air nozzle was on the side of it and now it spins way too freely. This isn't a problem. I have hundreds of 103 pots, so that's not a problem. But I did do that. I'm not going to put too much more effort into this because I've got literally another 3 amplifiers to fix, and they're actually amplifiers that I want for myself to keep. So I have way more interest in getting them sorted than this. The only thing is I wanted to sell this and make some money off of it, but if I have to spend another 2 hours taking parts on and off the board, I wouldn't sell it anyway, because it's just not, whilst it might last a number of years, I wouldn't feel right about it. You know, the next person that's got to work on it when half of the pads are weakened already because they've been heated up so many times from me pulling transistors in and out, you know. I'm just not one of those people that likes to sell dodgy shit. I do have morals. I know I know a lot of people don't, but you know, I'm not one of those eBay sellers or whatever you want to call them. I don't like it when it happens to me, so I wouldn't do it to somebody else. Like I said, I've already tested all of these before, so there's no need for me to do that again. I just made a right mess of that. One, two, two, 1, 2, 4. 2, 1, 2, 4. 1, 1, 3, 1, 6, 0. Alright, so now I can power it up and it's not going to go up into a pile of smoke. Anyway. So, I'm going to take the MOSFETs off now. I'm really running out of ideas on this one, I'm not going to lie. I might just quickly in this video too, I'll do that now. I'll just zoom out on this schematic and I'll go back over the initial problems, because I noticed someone comment on one of the videos asking what the initial problem was, and I wanted to reply to the comment, but the initial problems are so, how do I say, complicated. It would have just taken, you know, an insane paragraph to explain it, basically speaking. So I'm just trying to work out the best way of doing this. Alright, so the initial problem, without talking about it electrically speaking, I'm just going to have to take this phone call, give me a minute. Alright, sorry about that. So the initial problem, without getting into the electrical side of it, you would press the power button, it would turn off, it would turn off. It's a fault I've seen other people have on this mixer. I've looked on Google and other people have got the same problem. I haven't seen a fix for it. If you keep firing the power button, eventually it would turn on for longer periods of time until it would eventually stay on. Now, once you've got it to stay on, you go and measure the output on the back. There's something like 8 volts on one channel and 17 volts on the other channel, something like that. I can't remember. Nothing's changed on this. When I say original conditions, what I mean is what was noticeable when it was just in a box as a product. What I mean when I say the rest of the conditions is everything else I've uncovered since looking into it. So it had one voltage on one channel, another voltage on another channel. Then once I got into it, I found that the circuit, the comparator that controls the push-pull transistors that switch the FETs, is stuck high. Well, this is what I thought. We're going to find that out now, if I'm wrong. But it's not running on the 45 volt rails until the volume gets cranked up, and then switching over, it's already on the 85 volt rails. I don't know why. I've got some notes here. Let me just have a quick look. Oh yeah, that's right. We also had Q151 leaking rail voltage from the minus 85 volt rail, I think it was, into the minus 45 volt rail. You know what? I've got diff pair off. I can power it up now. Oh. So it was the positive 40 volt rail. Sorry. So the 84 volt rail was leaking some of its voltage through Q151. I'll show you where that is on the schematic in a second. It was leaking that back into the what's supposed to be a 45 volt rail. I'll show you. Q151's this transistor here. So it was passing voltage like this, bypassing the diodes here. Now, incidentally, sorry about that, I just hit the power button on my phone. Incidentally, the power supply on this, if we take a look at it, here's our low voltage, high voltage rails. It literally just comes back to capacitors, rectifiers and windings. There is no feedback off of this output. All the feedback's actually done off of the low voltage 15 plus minus 15 volt. Well, they're regulated, so whatever voltage it is here, but you get what I'm saying, right? The regulation's done. There's mute signal and thermal something. Anyway, all the regulation's done off of these windings here. So that explains why the power supply didn't really give a shit about having 60 something volts on the 45 volt rail, because I initially thought that was really odd that the power supply would even power up like that. But no, I took a look at the power supply and it's quite obvious. Power supply does not care. So yeah, there was that. No bias or base drive, right? So across the bias, VBE, transistor and the capacitor, no voltage, right? Across base to base, no voltage. It's a triple Darlington output stage. However, in between common ground and each side of the capacitor was exactly 6.2 volts. What else? I'm just looking over my own notes here. Yeah, both channels, the VBE multiplier had the same voltage on it, 6.2 volts relative to ground, but nothing across the capacitor itself or the circuit itself. Eventually I discovered that there was popped MOSFETs. Sorry, not MOSFETs, JFETs. I also discovered with the right mute transistor out that there, so that's where I got no output offset. Right, okay. So honestly, that's kind of irrelevant now anyway, because that's just one little problem I discovered. But at some point in the circuit, in the whole saga, I bought out this transistor, which this is the mute line. So anyway, I took this out, pulling current out of the diff pair, so not like literally pulling current out of it, I mean pulling it away from it, so there's no I've really worded that wrong. Removed the current flow from the diff pair, okay? When I did that, I believe that I lost the output offset, but I think that was just for the one channel. It's hard to remember. That's the thing. That's why I've lost my mind with this and just decided to start pulling parts and testing them. I have found so many strange little things going over this, And because it's all DC coupled and there's just so much that doesn't make sense, I just can't wrap my brain around it. So that's, yeah. If you're wondering what was wrong with it, that's what was wrong with it. A multitude of weird issues that just didn't make sense, because everything I've tested that would make sense for that problem happening was fine. So, you know, the areas I looked in that would cause, that I would think would cause those symptoms, seemed to be fine. And then obviously I discovered the pops K-FET, and I'm trying to work out, well, okay, how did that pop? Obviously it's VGS went too high. And I can see that that's happening too, because as I noticed, I think it was in the last video, yeah, the VGS went from 5.68 volts the first time I measured it to 6.68 volts the second time I measured it. And also when I put my meter on it, it starts at some higher voltage, like 20 or 25 volts or 17, I can't really remember. And through the 10 meg, whatever it is, input impedance of the meter, it slowly discharges and comes down. So there's some interesting things going on there. But I didn't design the circuit and I haven't reverse engineered it that much, so I don't exactly know how they're being driven. By the time I had gotten that deep into it, that I was back right to the start, the input stage, and had found the pop JFETs. That's pretty much when I started trying to measure voltages on the diff pairs and isolating stuff, and I still just was not getting anywhere. I will say this, after isolating the output stage, it behaves like a normal output stage. If I just dropped my multimeter lead, sorry. If I power it up, and I clip on to not signal ground, output ground. I think I said that wrong in one of the videos. If I have a look at the output, there's nothing at all. And the same for the other channel, they're completely dead. Absolutely nothing wrong with it. And you see I can turn it on. That's me putting my thumb between collector and emitter on the drive transistor on the positive side, and here's the negative side. You see? So there's nothing wrong with the output stage. That's doing exactly what it should do. I could build an amplifier out of it if I wanted to. I'm not going to, I'm just saying. You know what I mean? Like, there is something wrong further back, yet I have tested everything and I've pulled everything off the board and tested it out of circuit, and it still tests bloody fine. So I think this is a case of it's got leaky parts. You know, like this silicon that's leaking at a certain voltage threshold and it's not below that threshold. I could be wrong, we'll see, but at the moment it's, like I said, I've never been so confused fixing an amp. To be honest, there's only ever been like 1 or 2 amps in my life, you know, other than when I was a kid learning electronics, that I haven't been able to repair. And one of them, I still got it, and the only reason I haven't repaired it is actually because I need to order some modules for it. It's actually an Alpine car amplifier that's literally massive. It's huge. And the other one's an old Yamaha amp that I played around with when I was a kid and messed it up, and then came back to it later on in life and had a repair attempt on it, and yeah, I couldn't fix it, but I still got it. And that's actually what I was going to do, is I was actually going to pull everything out of it and try and put it back to original, maybe with a few improvements. But yeah, so this doesn't happen to me often, and it's pissing me off. I'm not going to deny it. So that's why I got the shits and started pulling all the components off in that section and testing them, because I'm just not getting anywhere. So I'll do this bit off camera now, because to get all these MOSFETs out, I'm going to have to flow solder into these holes. You know what might actually be easier? I might be able to just remove one or two resistors and just get my component tester straight on it without having to take it off the board. Because I remember I already took one off the board and that was not fun. I think that's what I'll do. I mean, let's just have a look. I don't think it's going to be able to read it in circuit because it's powered by a push-pull transistor driver stage, and it's connected to the rail too. I'll just show you the circuit. It'll make a lot more sense than me trying to explain it. That's the circuit there. So I don't think I'm going to get a good reading. I just hit my power button again. I don't know how I didn't stop the video. But yeah, we'll give it a shot. I don't see it working. Got a bit of solder on the legs. When I put that one back in, it's too thick to get the clip leads on it. And yeah, not to make excuses up here, I'm being deadly serious. Like, I really, really like to fix things and not give up on them, but I have so many things. I've made plenty of videos showing you guys all the stuff that I've got coming up to do on this channel. So to be quite honest, I don't actually have time to just keep mucking around with this thing every day. And that's the sort of person I am. If I've got something pulled apart to fix, I will keep going on it until I get there, or decide to give up and tell myself to just, you know, take the useful parts off of it that are good and throw the rest out. So yeah, I need to start being a bit more rational. I just don't like giving up on things like this. Yeah, this doesn't look like it's going to be very useful. I'll just try one other random one off the other side. Yeah, no, that's not going to happen. Man, I knew it as soon as I looked at the drive circuit. I was like, I'm going to have to take the things out. Alright, I'll do that off camera because I don't want to bore everyone. All I'm going to do is flow in a little bit of leaded solder. I'll do one on camera so everyone knows what I'm doing. This one has already been out before. I would have tested that then, so I'm not going to bother taking that out again. I'll take... I just don't feel like it is the MOSFETs. You know what I'm going to do before I do that? I'm going to take the comparator off. I'm starting to get suspicious of this comparator, because the comparator is what drives the MOSFETs. Well, what drives the MOSFET driver stage. I wonder if that comparator's got something wrong with it. You know, that's actually quite possible, and it's kind of silly of me for overlooking that, to tell you the truth, because we got POPs JFETs. They are referenced, their source line is tied to signal ground, and signal ground does go into part of the amplifier. I can't remember what relation it's got. I don't know. I'll have to look at the schematic and see if it's actually possible or not. But I mean, seriously, every transistor, every diode and every capacitor on this board tests good. What do you do in that situation? I must have spent a total of, I don't know, 12 hours or more just on the board, you know, just going over it. And at that point, it's just like, I don't know what to say anymore. Whoops. For those wondering that can't see, because my hand's in the way, I knocked the little capacitor off the board. I'm having trouble getting it back on the board because it's not lined up the pad properly. Jeez. Oh man, I think I should have just done that with solder paste and hot air. That has just not worked. Whatever. Yeah, so let's see what the rails have got on them now with no comparator. Be quite interesting. You've got to be kidding me. What? Okay, now we really need to go back. Because I was under the understanding... Alright, I've got to be missing something here then. What am I missing? I think I'm going to just pause the video and try and reverse engineer this circuit so it makes sense to me. I just need to work out what it's referenced to and what it's doing, where it's getting its references from. Because this might be because I've got stuff pulled out further back here. Just give me a moment. Alright, I don't know if I've got this wrong or not, but with this 10k resistor here, and that diode going also through like the 47k resistor, this junction here, and that diode going... The only pass I can see without being driven is turning it off. Hold on, let me think about this for a sec. Alright, I see where I'm getting confused. I've just made it bigger, and look, even at this size, I've just gone bigger 3 times. I think you'll see where I'm going with this. That almost looks like a flat line, like it's a depletion mode device. But it's not. It is 3 separate lines. It's an N channel. So I don't get what I'm missing here. Alright, the only thing I can think of is that when I pulled one of these MOSFETs out, only one of them's shorted if it's failed or the driver circuitry is wrong or something like that. And the one I pulled out was not the one that was causing the problem. But no, you know what I just realised? Hold on. We have both rails switched. It's not just on one side. You know what? There's absolutely no point in pulling these MOSFETs. It can't be the MOSFETs. I'm going to go back and have a look at the drive circuitry because I think I only looked at the drive circuitry for one MOSFET. Silly of me, I know, but now I'm starting to wonder. I don't know, there's something I'm missing here. And I still haven't decided what I'm going to do. If I'm going to just put it off to the side because I've got other things to do, come back to in the future, or if I'm just going to harvest parts out of it. If I can't work this out today, but I need to come up with a rational. Sorry about that. Having my phone around the other way around like this is really hard because every time I go to pick it up, my thumb hits the power button. It's not good. Yeah, I need to come up with a rational decision today because I can't have this on my bench just sitting here taking up space every day, stopping me from getting other things done. So, I think what I'll do is I'll stop the video. I'm going to go test the driver stage for these MOSFETs and come back and report my findings. But I think this is going to get packed up and put off to the side because, let's be honest, I'm not getting anywhere with it. Alright, there's something else I want to mention too, just in case that person that was asking what the initial problem was, I replied to you and I said that I would explain in more depth everything from start to end as to what's happened in here. So the reason I have a whole load of transistors removed, like the VB multiplier, now I've got these two diff pairs removed, but that's only because I removed a couple of other transistors earlier down that pull one of them down essentially, and without those transistors in, it would smoke the diff pair because it's got the whole rail voltage across it, and if it turned hard on, the 220 ohm resistors at the top and bottom of the diff pair and the bottom transistor on each side would have gone up in smoke, so I pulled them out. The other ones I pulled out were the ones, as I said earlier, in the areas I thought the problem was in. So that's why they're out. And the reason that there are some left on the board, well, there's three reasons I need to go over. The DTA 144 EKAs, I initially thought something was wrong with them because I didn't notice that they had a base to emitter resistor of 47k and a base resistor of 47k. So initially when I tested them on the meter, because it can't put enough current through a 47k resistor to turn the base on, they were reading open on one junction, so I thought that they were buggered. I ordered new ones, put them in, realised my mistake, and then put the old ones back in, so they're fine. Secondly, this diff pair and this diff pair, I am 1,000,000% certain there is nothing wrong with it because I have isolated the circuitry from either side of it, powered it up, and it literally has no voltage on either base. And if I touch the tweezers to say one base of one side, it goes high or low. It's functioning perfect as a differential pair. So I know 1, 2, 3, 4, 5, 6, 7, 8 transistors definitely are good. I know all of these definitely good. Okay, now here's the other thing I wanted to point out too. Sorry if this is a bit confusing, me going backwards and forwards trying to explain everything, but it's just that I haven't had much time over the last few weeks to work on this. Normally, if you watch most of my videos, you'll see I spend a couple of hours on something usually and get a considerable amount of work done. If not, I get it done in a few episodes. Apart from this one power supply that I spent way too long fixing up. I did fix it up, it's here and I use it, it's beautiful. But yeah, that took longer than usual. But anyway, this is the exception because, well, I won't lie, I lost a bit of motivation for it because, you know, it's just gone on and on and on. And that, one thing about me, I know if I lose my motivation for something, that I should not keep pushing myself to do it because I'll only lose my motivation more. So a few times I've put this off to the side and I've done other things. That, with me being busy the last few weeks, I've only come in and out of the room and spent an hour or two here and there, usually an hour at the most on it, before I've had to go and do something else. So because of that, there's been a number of videos. So I'm trying to just condense down. Alright, I just completely lost my train of thought. I thought I heard a knock at the door, and I was right this time. Anyway, I think what I was trying to get at is the fact that I've visited in so many small little pieces that there's a multitude of videos, and I'm trying to condense for you and anyone else watching that's new to it, you know, from start to end what's happened. So yeah, that's that. Now I want to point out something else here. The weirdness that I kept discovering in this circuit. Oh, excuse me. I don't know why when I drink coffee it gives me like these hiccup/burps. I don't mean repeatedly, just like one or two, but it's annoying. Anyway, so I'll just make that a little bit bigger. Sorry. That's probably better for you guys. So I could get this diff pair to behave how it should, and I could get this. It's a diff pair, but it's also got, it's mirroring something from over here, and this is mirroring this. You know, if you understand your transistors, you can see what's going on here. Anyway, the point I'm trying to get to is I could get this and this to function properly. But here's the odd thing that I couldn't get my head around. If I attach negative feedback or the max power adjust circuit to it, everything goes haywire. Also this little stage here, which has to get hooked up. I need these two diff pair transistors in to, you know, to let this be biased and powered for this feedback line that goes to the max power adjuster to work. So when all that's in, I've got all these weird voltages everywhere around here that doesn't make any sense, right? So that would make you think that it's coming from the output stage, but as I've just shown, and in previous video, which might not have been so clear because it was like 160, 180 millivolts on the offset on the output, that's just because I hadn't completely pulled everything out. There was still base to emitter resistors and current paths to the output, but as you can see now with the output completely floating, as I showed before, by shorting collector to base on the transistors I've got removed, you can see the output go high and low. So that's the thing, you disconnect negative feedback, and well, on one channel there was this 1 volt, 1.2 volt offset. I disconnected negative feedback, I think, and it was that or the mute transistor, this one up here. I think it might have been both, but anyway, that removed the offset on the output. So this is the problem I kept coming back to, and it was different for both channels. Like I said, I could get, by isolating the diff pairs, not from each other, from the rest of the circuitry, they would then behave how they should be, i.e. with like this disconnected, nothing going on here, no feedback, the output not driven. You know, I would just have 4R voltage across this one. This one would be I can't remember, like 4 volts, 4.5 volts, something like that. Everything made sense, but then I would hook everything up and it would all turn to shit again. And that's the thing that I couldn't get my head around. I found popped JFETs over here. I tested the op amp was fine. We've gone over this anyway, I don't need to repeat myself. Leaky capacitor, low value. Anyway, so I'm sitting there scratching my head trying to work out how there's a correlation between the two channels, because it doesn't seem like any of the channels have a problem that I can detect in terms of silicon. Like, I've checked all the diodes, I've checked all the transistors, most of them out of circuit even, and they all test good. And what's more, like I said, when I isolate circuits, they function. The only circuits I couldn't get to function was the bias and the max power adjust. I cannot get the correct voltages on this circuit here, and I cannot get any bias set up here. I cannot get the correct current to flow through this path. I cannot get this transistor to turn on at all, which it needs to get current to flow here. There was something going on over here. So I took these two transistors out. I did this off camera. That's why there's all these transistors in the bag. And that's what I was saying. Like when I pulled everything out from here and just had the two diff pairs, they started just behaving like diff pairs. So I left them in because there's nothing wrong with them. Anyway, before I keep wafting on and on and on about how confused I am about all of this, I'm just trying to explain so it makes sense to everyone, because a lot of people are probably wondering why I've invested so much time in this. Well, I'll tell you, I've never come across an amplifier that's got me this stumped over a problem like this. So, oh, little man. Hey, you can finally say hello to everyone. This is little man. Little man's literally one of the biggest cats I own. And the reason we named him Little Man is because, believe it or not, when he was a kitten, he was actually one of the smallest kittens I had. He grew up into a massive cat. I mean, this is just for reference, him trying to... Oh, damn, I'm hitting the power button. Hold on. Little man. I don't know if you can tell if I'm giving you a good camera angle, but this is him climbing up me. And I think you can tell size perspective. He's a big boy. He's a very, very big boy. This is very awkward with one hand. I should have got the tripod. Little man, I'm going to have to put you down. I'm sorry. Oh. Anyway. Oh, camera's upside down. Yeah. I've got really, really nice, friendly, cute cats. They're just beautiful. It's something I've actually always gotten annoyed with. You know, those of you that own cats, you'll know what I'm talking about. And those of you that don't, you might still not get what I'm talking about. Unless you're one of those people that don't like cats, and no offense, screw you. Yeah, like, I don't mean that. But I'm saying, like, honestly, I think, like, I like all animals. I just don't get people that, like, only like dogs or only like cats. You know what I mean? That's why I say screw you. You should like all animals, you know? We're the people that invaded this planet. Well, I mean, we're already here, but we made a right mess of it. And these poor guys now have nowhere to live, naturally, because of what we've done to the planet. So the least we can do is provide them with comfort and food and a home and that sort of thing, right? That's just my personal belief anyway. So I love animals. I live with a lot of these guys, and I won't lie, they do shit me from time to time, but I love them. They're beautiful. And they know when I get the shits that it's just because they're a little bit too playful. They know how much I love them. I think you can probably tell. Yeah, that's the thing about cats, right? So that's where I was just going with this. They're extremely wise creatures. And I own 13 cats. 13, yes, you heard me correct. 13 of them. And yes, I'll slowly introduce some more to you. You know, those of you that own cats, you'll know what I'm talking about here. But when you walk up the street past someone's house and you walk past a cat and you go to pat it and it runs away from you all scared, or it goes to attack you, or it seems confused, you know that cat is not being treated right. Because I can tell you, although I've got 13 cats now, I've had 25 kittens that I've given away, about maybe 5 or 6 that didn't make it out of multitudes of litters. I've had 2 that I got rehomed. I got the RSPCA to rehome them. No, they don't put them down. They actually rehome. It doesn't matter if it takes... A lot of people think that they put animals down. That's not actually true. I mean, unless it needs to be done for the animal's sake because it's suffering to survive, to keep living. But no, they actually will hold onto the animal for an indefinite amount of time until they find a home for it. So as someone that's aware of that, I gave them 2 kittens because after finding 25 homes, I was out of people to gift the last 2 to. So that's 26, 27. There was about 4 or 5 that didn't make it, so let's just round that off to say 30. That's undercutting it. Add on to that the 13 I own, and then before all of those, I had one cat before that named Chewy, and before Chewy, I had Tiger. So, I don't know, 40 something, 50 cats almost. And, sorry, I'm just standing here talking, looking at my bloody electronics, just staring over here into the distance. You guys probably want to look at little man. Anyway, and you know what I found in my experience? If you treat them with love and respect, they're all exactly the same like this. Little man, come to daddy. You know, and whenever I go past a house or I go to someone's house and their cat's scared or acts funny around people, it raises serious doubt in my mind because, you know, like I said, I've had probably close to 50 cats by now, and all my cats are rescue cats. So, well, these ones I can't say rescued cats. Some of the ones I have are, but the thing is they gave birth to kittens and those kittens grew up. And so I have the parents that I rescued off the street and their kids that are obviously not street cats because they were born here. But the point I'm getting at is, you know, between strays and cats that have been born on my own premise at home in a domestic environment, they've all turned out the same. So, sorry if I'm wafting on, but I don't know. I'm just a little bit passionate about that subject because it's something I've noticed just walking around the street and going to other people's houses that have cats. I've noticed very different personalities in their cats. And cats all have different personalities to each other. They all have their own unique facial expressions, their own unique personalities and traits. But what I'm saying when I say a different personality, I mean an antisocial towards human personality. And that tells me that the person just shouldn't really have a cat, because if you don't have time for your cat, just don't own a cat, you know? It's simple. Anyway, enough of that. Yeah, it's just something that I've noticed and it just gripes me. I guess it's probably because I've had so many cats that it's so apparent to me. Of all the cats I've got, only one cat I've got, and I've had her for about 2.5 years now. It could be possibly coming up to 3 years. This is actually quite a bit of a sad story. I named her Mamacita because she gave birth to some kittens in my backyard when she was a stray. And I had to make the choice of saving one of the kittens because it had a huge eye infection and it was going to die. Half its face was swollen up with pus coming out of it. It had left the other kittens and was just sprawled out on top of this wooden sort of like box I'd made for them in the sun just to die. And I saw that and I was like, well, I'm going to have to go catch that kitten. So I caught the kitten and I put a trap out because I knew the mum would come back looking, you know, for the kid. But I don't know what happened to the other kids. They disappeared. And I left the mum out there for probably maybe a month and a half before I caught her. And I never saw the kids with her ever again. So I ended up catching her too. And now here's the strange thing. She, as soon as I brought her inside, was unlike any other cat had ever rescued. She had been in a house before. She had been someone's pet, you know, like she knew what a couch was. She knew how to use a dirt box. She knew what the bowls were, food bowls, water bowls, dried food, wet food, all that sort of thing. I don't mean like how to eat. I mean like as soon as she saw a bowl, she'd run to it and start, you know, drinking. Like she just knew inside a house. I've rescued strays, like I said, and they've had to get used to everything. They walk around, they sniff everything, they look at everything, they get a little bit scared when every little new sound they hear. Like she wasn't like that. But the thing is, when I first got her, if I so much as looked at her, she would literally visibly shake and shit and piss herself on the floor. I'm not making this up. And no, I've not been able to find any visible like trauma, but I can tell you now, after 2 years of trying to say hello to her, feed her, give her cuddles, I can't pick her up. After 2 years, I can still only slowly walk up to her As long as I've got to say her name, I've got to go, Mamacita, so she knows I'm coming and that it's me, you know. And then she'll only let me come up to her and just pat her and give her head scratches and that sort of thing. I can pick her up and walk off with her down, into the living room and sit down on the couch with her, but she'll just immediately get up and go, and I won't hold her against her will because she's so scared, you know. And, you know, if you, there's been occasions where, when my missus first moved in for a while, I was really busy organising the house and just lots of shopping and just different things, and I didn't have much time for the cats. And, you know, I sort of realised that after about a month or so, and I go to give Mabasita a cuddle, and she literally started shitting herself again. She'd gone back to the start, is what I'm trying to get at. So, I don't know what happened to this cat, but someone fucked with it. And if I ever find that person, God help them. That's all I can say. You know, I don't believe violence is the option. I'm actually, I'll tell you a little secret about myself. I'm actually getting anger management counselling at the moment because I've had a lifelong problem with anger management. That's why all my knuckles are jacked up on this hand. From punching walls and getting into fights. It's just, yeah. But I'll tell you one thing, if I ever find the person that touched that cat, I'll probably need new knuckles on this hand too. That really pisses me off. I don't know, I've never met a more traumatized cat than this cat in my entire life. You can see the fear in her eyes, you know, you just look at her. Not me now after having her for 2 years, but I've got photos from when I first picked her up, and you can see the difference from then to now, just in her face. She used to, you know, ears back, eyes wide open, and the facial expression too. It was like she thought you were going to eat her or something. I'm not exaggerating. So, yeah, that's the only cat that I've ever encountered that was, you know, different to the rest, and still she's such a sweet cat. You can tell she's not, you know, feral or rude or anything, you know what I mean? She's a beautiful soul. She's just really, really scared, unfortunately. God bless her. But I hope to introduce you to her soon. It's just like I said, it's hard. I've got to pick the right time because I don't want to just go walk in there and pick her up when she's relaxed and, you know, make her wonder what's going on. She hasn't even been in here. The whole time I've had her, she's walked. It took her probably half the year just to start walking up and down the house. And, you know, she'd slowly venture into the dining. We have a back room. There's an old school toilet and laundry and a back room built around it, and then that goes into the dining room and kitchen, and then that goes into the living room, and then that goes down a hallway, and then the bedrooms, or should I say the bedroom, which is the front room, and my lab, which is this room, down the hallway. And so she started in the back of the house and would just sit there looking out the windows or hide in the corner of the room in a box or something, under a box. And then she'd start venturing into the dining room and then the kitchen window, and then sort of come into the living room but stay under a table or behind the couch. You know, only now she's starting to walk up and down the entire house, and she still hasn't even come into the lab. So, yeah. But when she's walking around and I can just, you know, go, hey, Mamacita, and, you know, pick her up, I'll bring her in here, or I might bring the camera out there and give her some cuddles on the couch or something so she's less inclined to just run off, so you can all meet her, because she's a beautiful cat. She's just so scared. That's the sad thing. And the thing that blows my mind is 2 years at least. At least 2.5. I'd say it's coming up to 3 years now. Time goes fast for me. Yeah, almost 3 years, I'd say. At least 2.5 years. And, you know, when I first started seeing progress in her and she was starting to come around, I thought, oh, great, you know, give it a few months and she'll be like everyone else. And, you know, 2.5 years later, you still got to put effort in every day. You know, give her pats and talk to her and that. And, you know, if you just go and ignore her for a single day, you can see her sort of go back. It's just, I don't know what happened to her. If anyone is a cat expert more than me, feel free to leave it in the comments what you think, or if you have any, this is something that's actually even more important to me, if you have any tips or tricks other than what I've been doing, which is just showing her love, to get her to come around, because she came around to a certain point and then just got stuck there. And the thing is, originally she didn't socialise with the other cats. Now she's completely normal with the other cats. You know, they sleep together, watch each other, play, eat together, everything. Sit there watching outside the window together, all that sort of stuff. You know? But with me, she just got to this certain point and she's stuck there, and I've never been able to get past that point. So, yeah. Anyway, sorry to get distracted in the video, but little man's still here. They like keeping me company in here. Anyway, so back to this. I just wanted to point out one other thing for you, if you're still there after all that. I did notice that, you know, there is some circuitry, so some lines that go back. So for example, this junction here, this thicker black line, goes all the way forwards to this junction here, which is reference to rails, and goes all the way to the 0 volt connector. It also goes to the base of this transistor. You know, there's a few things happening. Granted, through, you know, fairly high resistances, but there are still paths that I didn't look into before. So I just wanted to point that out. So I think I've covered everything now. I don't think I've left anything out. So I hope that answers your questions in regards to the amplifier. I know you didn't ask any questions about the cats, but other people have, so I hope everyone's happy to start meeting the cats. I'm going to set the phone down and get into this now. Okay, my apologies, but we have another interruption. This is the little ginger one that loves coming in here. Yes, you love your cuddles. I told you they were really cute. You want to play. Little man. Be friendly. These 3 kittens are not family to the other cats, so the other cats haven't been too friendly, but that's not what the fighting's been about. Like I said, one of the cats tried to take over motherhood of these kittens, or should I say successfully did, and she, ever since she did that, she also went really funny and started getting angry with my other cats, so yeah. She has started to calm down, so that's good. Because it was getting to the point that I thought I was going to have to give her away, and I've never ever done that with one of my cats, but I mean, I couldn't really see another solution. That's her that just meowed out there, if you could hear her. Little man. That's good. Alright, so Q145, Q146, Q144, Q143, that's going to be these guys. Oh no. These smaller guys. Alright, so I'm just going to quickly measure these in circuit. These are the transistors for the MOSFET driving circuitry. And then there's these two and these two. So the NPN and PNP for the push-pull driver circuitry for the MOSFET stage. And these transistors up here, let's check the schematic so it makes sense. Q135, Q136, 137, 138. Those are the transistors that are in between the comparator's output and the MOSFET circuitry. Just so that sheds some context on what I'm looking at. Oh, hey. wasn't looking at the screen on this side. Oh, must be in the wrong spot. Wait, what? Oh. Hold on. Am I having a brain fart? Yeah, I was having a brain fart. My apologies. I've got that on the wrong spot. Okay. Why do I keep doing this? Sometimes you just have those silly days, eh? Why is it everywhere I look for a problem, there's no problem? Oh, you bastard. I'm getting pissed at this point because I'm just like hoping to find something. If you wonder why every so often I test the junction twice, it's because I wasn't looking at the screen when I tested it. And I just want to make sure the voltage drops what it should be. Ah, man. There's these tiny diodes I'm sure I've already tested, but just for shits and gigs. And I mean just the ones in relation to this circuit. Should be one more somewhere around here. Alright, this is seriously odd. I hate to say it, but maybe I do need to pull the MOSFETs. I mean, quite literally, the only components left are the digital transistors, which we know are good, the two smaller diff pair transistors, which I know are good, the mute transistors, which I know are good, the output stage, which I know is good, and then, what's Q117? Hold on a second. Q118, Q117. There'd be a reason I left it on the board. Ah, yes, because I tested that transistor. I didn't need to take it out of circuit to test it. And I was sufficiently happy by the way it's functioning in circuit that it's working. That's right. Just again for shits and gigs. Why do I keep doing this? So, Confucius say, man who can't find broken transistor very confused. Well, I'll be honest with you, there was literally all of about 3 transistors that I did not have a look at in terms of measuring voltages across them in circuit. And there's a reason for that. Where they are in the circuit. Oh no, I did. Sorry, no, I did have a look. My bad. I was going to say because they can't possibly be causing this problem because it's almost in the output stage, but no. I did end up having a look at that yesterday. It just wasn't on camera. Well, I'm thoroughly baffled now. I think I'm going to pull the FETs out. This might be a poor decision, but before I do, just one more time, I'm just going to make sure these diodes are all good. Man. Hold on a minute. Oh no. Oops. Yeah, that was just that charging up. Hold on. Let me just have a look at the schematic for 1 second. There's probably a perfectly explainable reason for this. What is different between the high drive and the low drive? I'm just going to pause the video for a sec. All good, there's a diode between drain and... Oh no, that's not it. Hold on. Now I've got to go look again. Alright, I'm not going to lie here. I'm a bit confused. I think there's a couple of extra diodes in one circuit and a transistor, but I've removed the transistor. I can't see how the diodes come into play because it's got to go through a 47 ohm resistor, an emitter to base, emitter to collector junction of a transistor that's not actively biased, like on, and then through another diode. So I don't see how I'm getting that reading. Got me a bit confused. So I think I'm just going to take them out. Look, the other thing I was thinking of is that they're actually supposed to, the way it starts up is it starts up with the high rail switched on first, and as the BIOS and everything comes up, the comparator switches it down to the low rail, and then it only comes back up if it's requested because you've turned it up, requesting X amount of power. That was the theory that I had, still have, but I could be wrong. Actually, I don't know, this is gonna work. Nah, I'm gonna heat the component up too much. Ah, damn it. These are gonna be fun. Damn. That's just gonna be great. Well, all I can do is flow solder in like I did with that first one that I took out. Yep, that just went through the vias. So what I've done is I've got leaded solder and I've flowed it all the way through the via. See, now those vias are almost empty, at least going halfway through the board. Now, with a bit of luck, if I can find my tweezers, because I'm not touching that again. I always lose the most important thing when I need it in here, even after tidying up. One moment. You never believe this, they were in my pocket of all places. I don't even know why I would put them in my pocket. Alright. See how now, because there's only half a via full, I can get it out without having to heat it for too long, like what was happening the first time. So I can hold that comfortably, like very comfortably. I can squeeze on that real hard and not burn myself. I pointed out in other videos why I use this instead of the DCA 75 Pro for testing for failed components. So I'm not going to go over that again. Oh, I didn't press the button. You dummy. Okay. one of those jobs. I still haven't decided what I'm going to do, because this is the last time, at least for the next couple of weeks, I'm putting any effort into this amplifier. I've got too many other things to do. I've got my own amplifiers to build. I've got things to fix. I've just got a whole host of stuff to do for my workshop and for the channel. I've got component organizing to do. I've just got so much stuff to do. So I think I might actually just, you know, put it off to the side. And come back to it later. That might be enough. The annoying thing is if you start to press down with it to try and get better heat transfer, it screws up the pads. So if you want to keep it clean like that, you've just got to be patient. That was the right one I just did, wasn't it? Yep. So one of those holes is cleared through all the way, but the other two haven't. But we should be fine to get it out. It's not that taking components out bothers me so much. Like, I find that quite easy. But the thing is, the amount of time that I've spent on it. I'm one of those people that hates giving up on something, which results in me ending up spending way too much time on something where other people would just... No. Did my soldering iron element just die? It's weird, I've still got temperature on the screen like it's firing. Oh. Just my tip's dirty because I've got the temperature turned up. It's oxidizing quick. Alright. Let's get rid of those two hideous solder balls quickly. Might need to put some flux on there for that. I wonder if this is going to be blocked up again. Lately, every time no, it's not good. Lately, every time I go to grab my flux bottle, it's blocked and it doesn't want to come out. Beautiful. All right. I really don't think it's the MOSFETs, I'll be honest with you. But I also don't think it's the comparator. I did until I took it out and nothing changed. Like I said, I've got a funny feeling that it's supposed to start up with the MOSFETs on and then they turn off when bias and stuff like that meets, you know, as the circuitry comes up to power. Essentially, the reason they would have done that, I think, is to make it start up quicker. Like to get the bias current stabilized and all that sort of thing quicker. I could be wrong, it's just a guess. I just get that feeling I'm wasting my time here. I mean, what else can we look at before I go and pull the other two? Seriously, I've looked at everything. There's these transistors here, Q125, Q128, and Q127. Let me go back in the schematic. Okay, that's the self-biasing arrangement that they've got. Yeah, it is. That's the self-biasing network. Max power adjust runs off of another transistor that comes off that network. So I'm just studying the way the junctions are interconnected so I can make sense of what readings I'm going to get in circuit. So we've got a resistor. I just need to find out the value of R158 quickly. Oh, 243. Okay, that's up there. No, I should be able to just measure them in circuit. Let me just look at this schematic. We have low value base to emitter resistors. That explains that. But then the voltage in the other direction does seem kind of high to me. Now there are transistors that actually do have that higher voltage, but Q128, I'm going to make note of that. Q128. Let's see if the same transistor on the other side gives the same sort of measurement. It's going to be one of these three transistors. They're just laid out in a slightly different arrangement. It should be one of these first two. Oh, that's interesting too. That's Q130, Q128, and Q130. Let me just... Let's have a look at Q127. Just want to check this one more time. You know something? There's a base to emitter resistor, but the fact that the other junction's reading, you know, a little bit on the high side, I think just before I go and waste any more time trying to pull MOSFETs out and whatnot, I think I'm just going to have a quick look at one of these out of circuit, even just one of them. Because they're both wired up in the same configuration. They're both the same transistor on each channel. So they're both testing the same. So that's either because of the way they're in the circuit or because they're both gone. Interesting. I'm just going to measure this other one before I put that back in its circuit. Other two, sorry. Yeah. That's just the circuitry. So that literally is everything. I am gone on this one. I give up. Well, for now, I've got other things I need to do. I can't just spend the rest of my life trying to fix an amplifier. That doesn't make sense. Incidentally, I've had a look on Google, and I'm not the only person. This thing has two main problems. Well, when I say main problems, documented issues. One's this weird problem, and the other's where it doesn't turn on at all. And what that is a bunch of parts that basically go short circuit in the power supply. It's like a chain event, and you replace the shorted parts, a couple of transistors, an opto, a couple of resistors, I think it is, and it comes good. I've seen a few people with this problem, haven't seen anyone with a fix for it. So I really wanted to get it done for that reason too, just to help the community, to be able to put a video out there and say, hey, that problem, because I've seen plenty of videos of people pressing the power button to get it to turn on, and it still doesn't work when it's on. And you know, I'd love to be able to put a video out and say, hey, this is what's wrong with it. So I think I might just pack this up and put it off to the side instead of harvesting, say, the output stage and the resistors, the stuff that I know is 100% good. But yeah, I think we'll be coming back to this in the future. I think I'll just SATA everything up and put it off to the side. I do have some space in here for one, how do I explain it? One, like a project to put away. Now I've got some extra storage space in here. So I'll put this in that spot. Because right now I am out of ideas and time. Seriously. You know, I was really hoping it was going to be something like I overlooked a transistor problem in the output stage because of the base to emitter resistors or something like that. But after isolating the stage and driving it myself and it worked, I was just like, bugger. You know, I really cannot come up with an answer for why this is happening. So I think I'm just going to put this off to the side, get some other things done that I need to get done, and we'll come back to it in the future. We'll either fix it or harvest parts. I'll use, you know, the heatsink and the transistors for another one of my amp builds, and I'll use the power supply. Might, you know, I'll heavily modify it because I don't want a whole load of minus plus 15 volt rails and stuff, but you know, I'll keep the switching side of it and rewind a nice beefy transformer and build a huge switcher out of it, basically. Something like that. That's what I would do if I didn't repair this. But yeah, I haven't made my mind up on that yet. But as it stands, I kind of give up. I don't think I should waste my time pulling the other two MOSFETs out. That's just me being honest. Look, this is the PNP side. Oh, it's all NPN on that side. So I thought I pulled one on each side. Damn. But I mean, both sides are stuck on, and I don't see, looking over the MOSFET circuitry, the drive circuitry, why, even if a MOSFET was failed short and it was stuck on, I don't actually understand why that would cause it to turn the other ones on. I don't see anything in the circuitry, especially with the comparator removed, that would make it do that. I'll just have another quick look at it, just in case there's something I'm missing. Little man, I'm busy. Yeah, no, I'm really not seeing it. With the comparator removed, mean, you've still got voltage divider networks in between transistors that go to the dry circuitry, but yeah, I'm not seeing it. Anyway, I mean, I've left the schematic on the screen, so if anyone sees something I'm missing, feel free to leave it in the comment section, but I think for now I'm just going to pack this up. Like I said, put it to the side and come back to it in the future and either fix it or use it for something else. Yeah, sorry to disappoint, but it might not be a disappointment because, like I said, I might come back to this in the future and hey, we might fix it, and then there will be an answer for all those people online trying to find out how to fix this thing. I know I checked these diodes ages ago, but just for shits and gigs. And I was having a think about the low value resistors. Like, you know, I said before, oh, I should check the low value resistors. No, I shouldn't. There's no point. You know why? I've taken voltage measurements from all different points in the circuitry which would not have any voltage on those points, or diff pairs that wouldn't be functioning if those low value resistors were open. So that's ruled out too. This truly is a mystery. I don't feel bad because it seems like a lot of people have actually said that this is hard to fix and no one seems to have fixed it yet. So who knows, when I fix it, I might be the first. I'm sure there's some repair shop out there that's fixed it that hasn't documented it, obviously, like on YouTube or some forum, but for the most part, I can't find any documentation on this particular fault being repaired. So yeah, it's a strange one. Anyway, like I said, sorry to disappoint. I'm going to leave it off here because I'm just going in circles. And I'm going to get started on something else. So I'll see you all in the next video. If you like my content, please like and subscribe and comment down below. Thanks guys, and I'll see you next time.